Okay, let's start. So we are going to do a recap of all the Python that we have to use in the A2 paper 4 for computer science. So I will start with the very basics. First of all, we have the types in Python. Then we have the typecasting, operators, input, output, conditions, loops, string functions, 1D, 2D arrays, and exception handling. So all of the stuff. Okay, so first of all, we have types. So in Python, we are primarily working with int, string, boolean, and then there is no character in Python. It's only in pseudocode. And then we move on to typecasting. So typecasting is the idea of converting from one type to another. So the very simple example of this could be like, let's say if you have x is equal to 3.14 and you want to convert it into integer, so you'll just write, or you can just write y is equal to int of x, and if you print the value of y, so this would be an integer value then. Let's run the code. Okay, so I'll just comment this and it works. It now prints 3, and if I had printed x as well, so it would have printed 3.142 like this. Okay, then we have, so this is how we can convert from one type to another. Let's say we have another one. So I have, my message is now 3.142 as a string, and now if I want to convert this into an integer, I'll just, or if I want to convert this into a real number, which is float. So we missed one thing here. Float is the decimal number in Python. So if I write float and I print message here now, and then it should work now. It prints 3.142, and I can also print the types in Python. I can just write print type of message, and then it should print string, right? Because this is a string, and then if I just do message2 is equal to float of message, and if I print the value of message2, now it should print float, and it does print float. Then we have arithmetic operators in Python. They are the same one: plus, minus, multiply, divide. And then for the mod, we use we use percentage sign. This is the mod operator, which gives us the remainder, just like in pseudocode. And then we have the double slash, which is the div, which gives you the quotient value. So this is how we find the quotient by double slash. So let's do these as well. So when I say print 10 modulus 2, it should print me 0 because 10 is a multiple of 2. And when I say, let's say 11 divided by 2, this should print me 5.5. And when I say 11 double slash 2, this should only get me 5 because this is the division, integer division. Then we have the logical operators, and then we have the comparison operators. So logical operators are and, or, not, and comparison operators are simply greater than, less than, greater than equal to, less than or equal to, then is equal to. So this is equal to, not to be confused with the single equal, which is used for assignment. And then we have the not equal to. So this is the not equal to syntax. If you want to compare if two values are the same or not, and they would always evaluate to a true or a false, and same thing would happen in and or as well. So they would always evaluate to a true or a false. Alright, then the next thing we have is the output and input. So outputting is very simple. We just use print. So let's say we have a variable, let's say it's x, and I call it consi, and I want to print it alongside some other value. So I can just write, or let's say we have two strings. We have comp and then we have sci. So if I want to join these two strings, I can literally write x plus y, and then they would be printed. And if I want to add some spaces, I can add spaces manually like this. So this is the concatenation. So in pseudocode, we do it using the ampersand operator. This one. So this is done in pseudocode to join the strings, right? Then we can print values with the variables. So again, I can say print 21 comma x, something like this, and it prints 21 comma. Okay, so 21 will be printed as it is, and then x is the value. So we can join multiple values of multiple data types using a comma. Then a much simpler thing here could be the f string. So this is the format string. In this, let's say if you want to print something like this, I am studying comma x comma y as A2, as an A2 subject. So if you have a string like this that will have multiple variables, so we'll have to break it over and over again. So print f format statement is much simpler. What you do is write f and then you write quotation marks, and any variable that is supposed to be printed goes inside curly braces and everything else remains the same. So I am studying x and then space y as an A2 subject. Now if I run this, it prints the same thing, but this is just a neater way of doing it. And lastly, how do we take input? So input by default works as a string, takes input as a string by default. So typecasting has to be done. That means we need to convert it into a type. So if I say score is equal to input, enter score, and if I press enter and if I input 20, so this 20 would actually be a string. So what I need to do is I always should wrap it around the type I need to store it in. So if I say print score now, it becomes 30 as an integer, and I can double check it by using the type. So if I write 30, it says class int, right? So that's the idea. And we can convert it into float, we can convert it into bool. We don't need to write str because it's already in string format. Okay, then we move on to if conditions. The syntax of if conditions, how they work. So if conditions in Python are quite simple. So we just have if, then we have the condition, and then we have the call. So this would be a singular if condition. Then we have if, then we have the condition, then we have the else, that's it. And then we have the third one, which is if the condition is true. If it is not, then we go to elif. Okay, it's not supposed to be else if. That's in pseudocode. And then we can have as many elifs as we want. And then we can either end it on an else or we can simply end it on an elif. So this is purely optional. I'm writing it here, optional. So in Python, the indentation is extremely important because there are no braces used in Python, no brackets here for indentation. So indentation is extremely important, and always use tab button to indent, not spaces. Otherwise, sometimes the spaces are not calculated properly, not indented properly, and then the code leads either to an error or it just changes the whole logic of the program. So very quickly, let's say ask user to input a value and output positive, negative, or 0, something like this. So we'll ask user to input a value. Number is equal to int input. It should be an integer value. Enter a number, and then this prompt should always be present so that user can see what they have to do. And then I'll write if num is greater than 0, then print it's a positive number. Then elif num is less than 0, then we print it's a negative number. And then else if that's not the case, so I just print 0 as stated in the question. So if I run this, if I write 5, it prints positive, -2 negative, and for 0 it prints 0. So we just have to do it like this. And if I misindent anything, let's say if I don't indent it properly, it shows an error. And if I put spaces here, let's say if I put 1, 2 spaces here, this is again, it will work, but again this is a bit risky. Okay, so always go for tab, or just if you don't want to press tab, just go back to the end of the line, press enter, it will automatically indent. So this is your if, elif, and else. Then we have nested conditions in Python. Nested conditions, again, same thing. I'll just modify this question a bit. Ask user to input a value and output negative and 0. And first check if the value is an even number. Otherwise, output error. So now we have to use an if condition within an if condition. So I'm going to pick the whole code and I'm simply going to tab it, indent it, and then I'm going to check if number modulus 2 is equal to 0, which is simply just checking if the number is even. If that is the case, then one of these conditions would run. Otherwise, for the outer condition, it should be else, and we just print an error for any number that is not even. So this is how indentation works. Okay, so if this if condition is true, then either this if, elif, or this else works, or if this condition is not true, then we directly go to line 15. So these are the whole if conditions that we need. And just a reminder, if conditions will always run once. So if I input a 0 here, even if 0 is supposed to be an error, let's say if I have 9 here, 9 is supposed to be an error, but it's not going to input the value again because if conditions work once, so you need to put them in a loop if you want to repeat them for multiple times. All right, then the next part is for loops. So we have two types of loops in Python. We have for loops and we have while loops. So for loops are the count control loop, and then while loop is the conditional loop in Python. That means it runs as long as the condition is being met, and then count control loops for a fixed number of times, fixed set of iterations. Alright, so now there are three formats to count control loop, for loop, that is range and start to end, and start to end, and to a certain step. Okay, so if we have a simple for loop, so let's say print values from start to 10. So print for I in range. So in and range is supposed to be the keyword, and this could be any variable here. It could be a dash, it could be 8, it could be I, it could be count, anything of that sort. So for I in range, and if I write 10 here, and if I print the values of I, so it will print values from 0 to 9. So it essentially means the first 10 values. Let's make it 5. So it means first 5 values starting from 0. So the last value of 5 is not included. Okay, it only runs till 4. Then let's say the question says you have to print them in the same line. Print them in the same line, and to make that happen, what we have to do is for I in range, and at the end of print statement, I'll write end is equal to this. Okay, by default, it goes to the next line like this. So we are just going to overwrite it and we'll put a space. And if I run it now, it prints 0, 1, 2, 3, 4 in the same line. So this would come in handy in some questions in the past papers because sometimes they ask you to print it in the same line. Okay, so for this question, I'll just keep on printing in the same line. Then the next format is to print a value from start to end. So let's say I want to print the values from 10 till 15. So if I write 10 till 15 here, and if I run the code, and we need to add an empty line break here, so it goes to next line. Okay, it prints 10, 11, 12, 13, and 14. Again, you have to remember that since we are using the range function, it starts from, it doesn't include the last value. So we have to add it individually. So I'll write 15 plus 1, or I can just simply write 16, and then it will print all the values from 10 till 15. And then the last step is, the last format is using a range from start to end and then having a step function. So let's say I want to print all the even values between 10 and 20. So I will write 10 all the way till 20 plus 1, or simply 21, and then I can either do it this way, that I check every time if I modulus 2 is equal to 0, and then I print the value of I, and I'll also print them in the same line like this. So it prints all of them in the same line, all the even values. We need to add another line break. Okay, so it prints 10, 12, 14, 16, 18, and 20. Or the other method is that I can just skip over using the step method. This means that instead of changing the value of the variable of I by 1, so instead of going 10, 11, 12, 13, 14, we can do 10 plus 2, which gives us 12, then 12 plus 2, which gives us 14, so on and so forth. So I'll get rid of this. I'll unindent it, and now if I run it again, it still gives me the same output. So what happened here is that we started from 10, we printed 10, and then this is the step value. So 10 plus 2 becomes 14, then 16, then 18, then 20. And if I make it, let's say 5, so we'll have hops of 5. So we'll have 10, 5, 15, and 20. So this is step function. This also comes in handy here and there. Then the next thing we have is the while loop. So while loop does not have any counter, does not have counters or range, although you can use range with the while loop, but we'll keep it separate from the for loop. So we'll use it in the conventional way. So what I have to set is, let's say if I want to print values from 0 to 5. So what I'll have to do is I'll have to actually set the index or a counter to 0, and then I'll check while the condition is true, and then that's it. So while I is less than equal to 5, as long that is the case, I'll print the value of I, and I'll increment the count of I by 1. So I'm incrementing the count. And then if I run it, so it all prints values from I from 0 to 5. Like this. That's it. And let's say if there is another question, maybe print the square of all values inputted until minus 99. So for that, again, we have to use a while loop. And in such a case, we have to input in the loop and before the loop. So first I'll input the value, let's call it val is equal to int input, enter number maybe. And then I check while the val is not equal to minus 99. As long as that's not the case, I will print the square of value like this. And if I run it now, this goes into an infinite loop. So if I write 20, it will forever keep printing the square of 20 because I'm not recalculating or re-inputting the value. It will forever remain 20. So 20 is not equal to minus 99. Yes. And it will print the square same again and again. And this happens till infinity. So I need to bring this line inside the loop again. So I don't send it into an infinite loop. If I write 20 now, it's 400. Now if I input minus 99, it ends. That's it. So this is all there is to while loop. And now in the while loops, you can include any sort of if conditions, and you can even include any for loops, etc. Then the next thing we have is the nested loop. So next thing we have is called the nested loop. So nested loop is a loop within a loop. So for I in range, let's say 3 or maybe 4, and then for j in range 2. And then if I print the values of I and j, we can add tab spacing as well by using /t like this instead of putting manual spaces. And let's use a print statement here, the format string, printf. So we have I/t j. So I'm just printing the values to show how it works. Okay, so I is the outer loop and j is the inner loop. So outer loop will remain fixed until all of the iterations of the inner loop are done. So I is 0 and then j becomes 0, then 1, right? Or maybe we increase the iterations here. So for when I is 0, j becomes 0, 1 and 2. The inner loop runs completely. Then j becomes 1. So then I becomes 1 and then j becomes 0, 1 and 2. Then I becomes 2, then j becomes 0, 1, 2. Then I becomes 3 and then j becomes 0, 1, 2. So until all the iterations of the inner loop are done, you do not change the outer iteration. And then you can write any code here that is supposed to, so code here will run before going through all inner iterations. And this is very useful when we are talking about arrays and especially in bubble sorting. So we'll look at it afterwards. I just want to show the syntax. Okay, then there are some library routines in Python. So we have already done these. We don't need to do them. So we have the round and the random. So round is very simple in Python, and so is random. So let's do random first. Okay, let's talk about random first. So in order to use random, we first have to always import random. And in order to avoid random dot something over and over again, we can just write from random import star like this. So we don't have to rewrite random over and over again. But if I just print the value of random here. So it prints me some random values between 0 and 1. Alright, so now let's try to print some random integers. So in order to do that, I'll use the function called randint. So let's have n1 is equal to randint, and I can specify a range. So it tells you in the parameter as well in the function definition. So it returns a random integer including both the endpoints. So it doesn't work like the range function, it actually includes the ending value as well. So 1 to 5, and if I print the value of n1, it prints 2, then 1, then 1, 3, 4, so 5, etc. And this is how you can generate a random integer in a certain range. And then if you want to generate negative numbers, you can just write -10 to +10, and let's keep it n1, and then it works the same way. Right, so that's the idea of random, and you can use it to generate values in any range. Alright, then the next part is the round function. So round function is very simple. Let's say we have a value. We have value of pi 3.1426 something. And then if I want to round it, so let's call it new pi, and that is round. And in the round function, I can send the value of pi. And if I just print the value of new pi, it will just print me 3. So it will round up or round down based on the number. Okay, 3.5 becomes 4, 3.1 becomes 3, and if I wanted to round it off to the nearest decimal places, I can just write 2 here. So now it would be 3.14. Simple. Then the next part is the string functions. So string functions, these are all allowed in the syllabus as well, so you can use them without any issues. So let's have some sort of a string. Okay, so message is equal to, let's have Attack on Titan maybe. Okay, first of all, we can use this function called upper and lower. So if I just want to print the values, or let's say we have u message, so that would be message dot upper like this. And if I print the u message, then it becomes uppercase, so it becomes Attack on Titan. I missed a C here. So Attack on Titan like this. And then I can do the same thing for lower. So L message is equal to message dot lower, so it will convert it all into lowercase. This is particularly useful when you have to convert the cases into the same case, especially if you are asking the user to input an email address. So email address must be in lowercase, or if you write in uppercase, it must also be converted to lowercase. So we use these functions there and then. Then we have the slicing. Okay, so we'll talk about slicing in a bit. Let's talk about string comparison. So in some questions they might ask you, check if your string contains a digit from, or contains an alphabet from A to Z. Okay, in order to do that, let's say if we have a simple character here, character is equal to, let's say B. So you can actually perform string operations on the comparison operations on this. You can just write if character is, the value is greater than A and character's value is less than equal to Z. If that is the case, then this should be, let's say, print true. Now this is implying that we are essentially going to check the ASCII values of these characters, and then we are going to compare them with each other. Right? So that's the idea. We can actually compare strings like this. Okay, before we go on to the next part, we should look at how we can iterate the strings. So how can we iterate it? So in Python, strings are treated as arrays or lists. That means if I write, so I'll bring back the same message, Attack on Titan, and if I print message index 0, it will print me A, that is the first character, and if I write 1, that will print me the second character, so on and so forth. So just like the arrays. So that means I can actually iterate through all characters of a string. For that I write for, let's say, character, or anything for character in message, if I print the value of C, it will print me all the characters one by one. Either I can do it this way. Again, I'm just printing it in the same line for convenience. Okay. Either we can do it in the same, do it like this, or we can use the len function. Iterate using len function. So this was using the in function. Okay, so if I want to use the len function, for that I'll write for, let's say, C in range, len of the message, the length of message, how many characters there are, and then I can print message index C. And if I print it like this, see, it prints the same line in the same way, all the characters one by one. And I just need to add a line break here, and that's it. So here I am just going through all the characters one by one. Python breaks them down for me. Here I'm looping through till the length of the string, and I have the range function here as well. And then I'm saying pick the current string and go to the each index. So C would be 0, so it would print you A, then it would become 1, it prints T, then A, then C, then K, then space, so on and so forth. So both of the methods are fine. This method is particularly useful when we have to, let's say, store the index at some point for a character or for something. Let's say the question says output the index where you found, let's say O. So you'll actually use this method then, because in the for blank in string method, you cannot return the index, as it will just go through all the characters without catering to the indices. So that's the point. Then we have next two functions, which are strip and split. They are extremely important in Python. So the strip function is used to remove spaces from the strings. So let's say I have a movie, let's say I have Avengers, and I have spaces in between and in start. Okay, so strip is going to remove spaces or any custom character from the string. Okay, so what does it mean? So if I just print movie dot strip like this, so it will just get rid of all the spaces. If I print it without this, then it will have all the spaces there. If I print it without, see, the spaces, and then if I say print movie dot strip like this, then there are no spaces. Similarly, if I just put asterisks here, and I can get rid of them as well, I can just put asterisk inside the bracket, and then those asterisks would be gone. So it doesn't only work on strings, on spaces, it works on any custom character as well. But for now, we'll just make it work on strings. Then we have the split function, which is again extremely important, especially in file handling. So what does the split function do? It will split the string into a list based on a separator. Okay, what does it mean? So let's say I have a message. I say that there's some ID, then this ID is followed by the message or the text, then there is the ending message. Now I want these three components to be split into an array so I can read them separately. So for that, if I just use the word message.split, or in fact we can just call it a format. This could be just the format. This will be the format of our message, and let's give it actual value. So it could be ABC and text could be A2CS and the ending would be Y, something like this. So when I say message.split and I want to split it also, the separators are comma, right? The separators must be consistent, otherwise it won't be possible to split them. So I'll split them on a comma and I'll assign a list on the left side. Let's call it components. And then if I try to print the value of components, it will actually be an array like this. So it has ABC, then A2CS, and then it has Y. And because there are spaces in between, so it puts spaces here as well, like this. And if you want to get rid of the spaces, you need to apply the split function. So we'll strip function, and we'll see that when we talk about arrays in a bit. So this is how we can convert any string into a list based on any separator. So it could be anything else. Maybe you have dash here another dash here, so I'll replace it with dash, and then it's again split, right? So we can then apply all the array algorithms by doing it this way. Then we have string slicing. This is a way of extracting substrings basically from source string. So like we discussed before, strings are treated as lists in Python, so we have to keep that in mind. So again, we have a message A2 comsci maybe. Now if I print message index 0, this prints me the first character. So it prints me A. And if I print message index -1, this will print me the last character, which will be I. Right? Now, if you want some characters in between, so in order to do that, we can just use these colon format here. So from start to end. So if I want to print message from 0 till 3, so first 3 characters, sorry, first 2 characters. Again, this works like range, so this value wouldn't be taken into account. So it will go from 0 to 2. So it prints A2. And if you want the first 4 characters, so you will write 4. So this is how it will work. This will bring first 2 characters, and this brings first 5 characters. So if you want first 5 characters, you will make it till 6. So you get the first 5 characters. 0, 1, 2. Okay, this is 3 characters and this is 6 characters. Because there was a space, I just saw that. So let's remove the space to avoid any confusion. Yeah. So we have the 3 characters and then you have the 6 characters. Alright, so but again, since it's starting from 0, so it won't go to 3, it goes from 0, 1 and 2, which is a total of 3 characters. Then if you want to omit any start or stop, so in order to do that, you can just write print message index, let's say colon 5. This means that you are going to start from the default value 0 and then you'll only go till 5. So 0, 1, 2, 3, 4, right? So this will omit the value from the start. It just means start from 0. And if you want to omit the ending value, or you can say go from nth index till the end. So for that we write print message index, let's say 2 colon end or 3 colon like this. So it means go till the end, just start from the 3rd index. So it will start from the 3rd index like this. So that's the whole idea. And if you want a quick reversal of any string, for that we can write print message and write colon -1, and if I do that, it will print the string in reverse, although this is not really recommended, especially in a question where they ask you to reverse a string, not to be used when question asks you to implement it. Okay, that is not allowed. And then one last thing, so if you want to do it in a sort of a program, so print a string in reverse. So again, we have the message, we have A2 comsci. So if I want to print this in reverse, we need to use a for loop and we need to run it in reverse. So for I in range, we can run it in reverse by starting from the length of the string and going till 0, and in step we'll do -1. Okay, so we talked about step function in the for loop. It can move in both directions. It can move forward or it can move backwards as well. So I'll just print, so if I just print the values of the message at each index, and end is equal to like this. Okay, it says that it goes out of the range. So length of message okay, there's a small mistake here. So we have to start from length of message -1, okay? Because length will include all the characters. So it would be 1, 2. Again, let's get rid of spaces. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So since Python starts from 0, it would count 8 characters. So that's why we have to do -1 here. So this is the starting point. Then this is the point we have to go to, because in the range function we always end up reducing the last value, so we don't go till this value actually, so we are actually going till 0 in this case. That is the ending value, and then -1 here, this is the step function. This is the number of this is the value by which we'll reduce the value of I every time. So now if I print it, it prints the array, the string in reverse. And if you want to save it, we can just create an empty string. Let's call it reversed, and we have it empty. And then we can just concatenate it one by one. So reverse plus equal to, or reverse equal to reverse plus message index I, and then I can print reverse in one line like this. And we can get rid of the whole thing here. And that's it. Works perfectly. Then the next thing we have is 1D array and 2D array, and for this part we'll be also looking at function and procedures. Very simple in Python. So structured programming or modules. Let's call it structured programming. Okay, so we have procedures and we have functions. I'm not going to go into their details. So when we have a procedure, we'll just write define, and let's call it maybe add, and we'll have two values, n1 and 2. These are the parameters. So this is the name. These are the parameters, and then we put a colon, and then this is the body of the procedure, right? And if it is supposed to be a function, then the only new thing would be that there would be some sort of a return keyword here. And then after return keyword, this code is unreachable as return terminates the function, right? Okay, so now we go to arrays, and we'll be using the modules here. So in order to initialize, or in order to declare an array, so let's start with, so declare an empty array. So for that, let's call it, let's say, scores, and this is how it would look like, empty, and we'll need to put a comment into next to it. So this is how it should be done in the paper as well. We must, if they ask you to make it empty, you need to give a proper declaration for it, because Python is dynamically typed, it will automatically reduce the type. Okay, then the question might ask you to initialize all the values to 0. Now there are two ways of doing it. One is the easier way, one is the bit lengthier way. So in order to initialize the values to 0, we can say scores is equal to 0 for I in range, whatever the size is. Okay, so they might tell you the size of the arrays. Size of scores array is 5, let's say. So we'll just write 5 here, and then if I print the value of scores, it will print 5 zeros. Or the other way is that we can use this, and maybe you want to input specific values here, so we'll use a loop, and in fact we'll do that in a bit. Yeah, okay, so let's create another array. Now the question is talking about adding into the empty array. So in order to add in the empty array, we use the append function. Okay, this only works on an empty array, and I'll show you why is that the case. So let's say if I print the value of scores, it already has some values. So if I write scores.append, and if I write 99, so technically this is a very common mistake that students make. They assume that 99 would go here, when in reality 99 would go at the end of the array, right? So this is wrong. When the array is already initialized with some values in it, you are not supposed to use append function unless the question says that you have to add the value at the end. So append will only work on an empty array. So if I create another empty array, let's call it ratings, and then if I use the append function here, then it would work perfectly. So ratings, and 99 would go in the correct position, and then maybe 12, and it goes in the correct position. Now if the array is already initialized and you want to place values there, so again if I print the value of scores, there are already values there, so we'll just initialize it again here like this. So these are just placeholder values. Now we want to replace the zeros with actual values, so for that I would need to use a for loop, and again this works like the strings. So for loop, Or yes, so we'll have to use a for loop here. So I'll write add values in array. So I'll use a for loop for I in range. Again, let's use another variable for j in range, length of the array, which is 5, because we assign it 5 as the total number of values. And then I will say that at the current index of scores, so scores would start from index 0. So this is index 0, 1, 2, 3, 4. At every index, go and put some value. Maybe it could be j plus 1. Okay, so if it is 0, it becomes 1, 1 becomes 2, 2 becomes 3, 3 becomes 4. And if I print the value of scores, this is just an example. Okay, so 0 becomes 1, 1 becomes 2, 3, and then 4 and 5. So this is how we store values in an already initialized array. Or in another case, you can actually take input into the array. So you can ask the user to enter values. And if we do that, 12, 2, 4, 6, 8, and it prints all the values that we just added. So this is the most important part in array. This is the index. The index starts from 0, then 1, then 2, then 3, then 4. This is the position, and this is the name of the array. So this is how we add values into the array. And if we want to remove a value which is not technically expected in the paper, but you should still know this. So if I print the value of scored, it is this. So if I say del scores index let's say index 0, so first value is 1. So now if I do it again, so now 12 would be gone, right? If I make it index 1, so now 6 would be gone. Sorry, the other value would be gone. So this is how we can actually delete index at a time from the array. And you need to remember that this value wouldn't come back, so you cannot retrieve this value once it's deleted. All right, so with this done, then iteration we have. Okay, now let's say we have the array scores. I can print all the values like this. So let's bring back some random values. Scores is equal to 21, 5, 90, 12, and 77. If I want to iterate through all the values, I'll just use a for loop. So I have both options, or let's say val in scores and print val. So it will print all the values. And in fact, I'll use this approach to find the sum and average as well. So if I'm setting total to 0, and then we can just total plus value, and then for average we'll say total divided by length of the array, and I can print the average as well, something like this. So it prints the sum and the average. You can get rid of this, and let's print the total as well. So 205 at 41.0, or we can do it in the other way, that is using the index. So we'll say for IDX in range len of scores. So that means we'll iterate for all the number of values in the scores, and then we'll go to each value at the current array's index, which is IDX. So IDX would be 0, then 1, then 2, then 3, then 4, and it prints the same value. So the same thing. We use this when we have to refer to the index, and we use this approach when you can say that index is not needed, only the values, right? So in order to initialize, we'll do the same thing. In order to first, in fact, declare it, we'll write, let's say we have something called the matrix, and then this is how we can declare 2D array, and we'll call it int array. Okay, again, 2D arrays or 1D arrays are supposed to have the same data types, but in Python we can differ the data types. And if we want to initialize it, so let's say we are given the number of rows, which are 3, and then columns are given as 2. If we want to initialize them with some initial empty values, so for that to happen, we need to write this code. So it will be matrix is equal to, let's say we want to initialize it with zeros, with all zeros. So I'll write in this inner part, I'll write about the column. So 0 for C in range of columns, and then this outer part here would become for the rows, and this would be for our in range of rows. You can obviously change the variable names. And if I print the value of matrix now, this should be row. Let's make it rows as well. So now we have a 2D array with 2 columns and 3 rows. So this is what I'm doing here. I'm essentially creating a 1D array, and I'm putting 2 zeros in it, and then I'm replicating the same thing for the number of rows that we have in the program, that is 3. So this is the idea. Then if we want to add values into the 2D array, so we'll use the same logic. We'll treat them as simple 1D arrays. So if I have matrix 0, and if I just print that, so it will give me row 0, and then if I do 1, this will give me row 1, and if I make it 2, then this gives me row 2. So I can just go ahead and append a value in a certain row, and then it would just print me, if I print the matrix again, so now 3 has been added here, right? In fact 2 times, because I ran the code twice. Then removing works the same way. So in this case we just have to write del matrix, and we have to give 2 indices now, so that it would be the row number and then it should be the column number, like this, and it would end up removing the value. Then we have iterate. Now if you want to iterate through the 2D array, it has to be done using a nested loop, because there are multiple rows and multiple columns now. So let's bring back the array, maybe 0, 1, 2 and 5, 7, 8, something like this. So in order to iterate it, so again there are 2 methods: iterate using indices, and the other method is to iterate using the values. So if you iterate using indices, so for that I just have to write for item in the matrix, and if I just print the item, so again the 2D array is a combination of 1D arrays, so it will literally print the 1D arrays in it, right? And if I want to print each value at a time, so I need to write for, or we can, let's call it for array in matrix, and then for value in array, like this. And if I print the value now, so it will print me the value separately, so 0, 1, 2 and then 5, 7, 8, right? So that's the idea, and this should be AR. So I'm accessing one array at a time, 1D array, and then within that 1D array I'm printing the values one at a time. Or we can do it using the for loop through using the range. Okay, now in order to calculate the size of the 2D array, so the rows would be simply ln of matrix. This would give us the number of rows, which is 2. And if we want to get the number of columns, that is a bit different. So we have to get the length of the matrix arrays any row, right? So here I'm specifying that get how many values are there in the row 0. So it would tell me that there are 3 values in row 3, so that would be the number of columns. So iterate using the values. So now we have for, in fact this should be values, and then this should be indices. So it becomes for row in range row, and then for column or for C in range column, and then print the values of the matrix at this row and at this column. So I print the values, again it gives me the same thing, like this, right? And there might be a question in the paper that asks you to print the 2D array in tabular form, and in order to do that we'll just make a procedure. Let's call it print matrix, and then we have to do the same thing. I'll just copy it from here and I print it, and when I call print matrix like this, and I'm assuming I am using this matrix from above, so it will print the same thing like this, but you want to print it in tabular form, so the columns must be printed on the same line, so end with a space, and then rows should be separated, so an empty line after each row. Now it works perfectly. So it'll 0, 1, 2 and then 5, 7, 8. Then if you want to do the sum and average of a 2D array, simply same method. So we'll have, let's call it matrix average, and then we have we have to go through all the values. Now since we don't need the indices in this case, so we don't need to actually use the for I in number of rows and number of columns, we can do the iteration on values directly. Let's say average. Okay, so for let's say val in or for array in matrix like this, and then for val in array, and then we'll just sum all these values together. I'll set the total to 0 initially, and once that is done, I'll divide the value by the total number of elements in the 2D array. So that would be from the length of my array, which is length of matrix, multiplied by length of matrix with the number of values in any certain row, and I'll return this value. So this would be my main function, and then I'll print the value. Average of matrix would be avg. So we print it and it gives me something like this. So this is a much simpler way in case the indices are not needed. Then the next part is exception handling. So this is just some code that we use to avoid crashing the program on runtime error. So we have multiple exceptions like zero division error, index error, file not found error, etc. So for this, we'll primarily be using try and except. Try is the code that we attempt, except is the code that will be executed if the error occurs. And then we have else, which will execute if the no error was there. And then finally would be the code that will execute regardless of the errors. Okay, so very simple example. I'll just get rid of this part for now. Okay, so if I run this, if I divide 12 by 0, which will generate a runtime error, so it says you entered an individual invalid value, right? And if I do it by 4, it prints, in fact I need to, so it should be 12 by 4, and it prints that since it ran correctly, so the else part would be triggered and it would be 3.0, right? So try, except, and then finally would print regardless. So that's the idea. It helps us not crashing the program. So again, 12 by 0 would trigger, you entered an invalid value. Instead, if I had just done 12 divided by 0 in the program, it would have given me a long error, and then it wouldn't have done anything else after crashing the program. So I would have to fix the error and then redo it. Okay, with this done, we move on to the file handling part. First, we'll look at the text file, then we'll look at the binary files. And this will be the last part of the video. So file handling in Python uses open and close, and then we have multiple functions. We'll be using strip and split functions, all the ones that you've done before. So in order to open a file in write mode, we use W, and first we give the file name, and then we use f.write to write into the file, and then the file, the write function does not go to next line automatically. So we have to use the /n operator at the end of each line, so it adds a line break, right? So as we're doing here, /n/n/n, and then we always have to close the file, otherwise it won't get you full credit. So if I go ahead and if I open the sample file here, so it has all the lines that we need, and there's an empty line here because we added this /n at the end. So if I get rid of it, if I open it again, so it shouldn't be there anymore. And then again, so write mode opens the file in overwriting mode. Okay, so if the file already exists, all the contents would be overwritten when you open the file again in write mode. Then if you want to append into the file, that means you add new content without overwriting. So you open the file in A mode, and then you add it at the data gets written at the end, and then you can just save it. So if I reopen the file, so it should show me line 4 appending the new data. Yes, it has been appended into the same line because I removed the line break from above. So line break should be there in order to add in the same line. Then reading the file. So in order to read the file, we have to use a for loop for something. Again, this is not a fixed variable name in the file f, which is a file handler. We just read the line and we strip the values one by one, and then we can print them on the screen, and here we go. This is printed on the screen. I'll just change this to line 4 like this. If I run it again, so it shows me all the lines appropriately. So this is how we read the file for all the lines. Then what if you want to read multiple lines at a time? There would be a question at times that would say that you have to read the lines in a pair of 2 or in a set of 3. So in order to do that, you first of all have to open the file, you have to read one line, then you run a while loop, and then you read the second line, and then you read the third line, and then you can print all the values. So if I print the values now, it prints line in X, this is in Y, and then this is in Z. So if I had more lines, then they would have been switched every time. So once I printed all three values, I'll reread line X, I'll go back, since it's not empty, I'll read line Y, I'll read line Z, so on and so forth. This is only going to be applicable when the question specifically asks you to go through multiple lines of file at the same time. Then if you want to count the number of files in the program, to count the number of lines, we open the file, we in the read mode, then we set the line count to 0, we go through all the lines using a for loop, and we increment the line counter by 1, and then we close, and then it simply gives the number of lines, which is 4. Then if we want to iterate through the file till the end, and we want to save the values in the array, so if we have these lines, I'll create an empty array, then I'll loop through the file, and I'll simply just strip the values to get rid of any spaces, leading and trailing, and then I'll append them into my array, and then I close the file. And then once we do that, we have this array here ready that was converted from this file. Very simple. Or if you don't want to use append, then it's necessary that there must be some initial values here. So let's say there are 4 lines, and then you would need to replace it with a for loop for I in range. You would have a counter here, and then you would need to place the values using the simple array method. Then writing the lines back to a new file from the array. So we open the file, then we use a for loop, then we just write the lines into the file, and at the end of every line we will have the new line break, and then we close the file, and then we have the values written in the file. So this is an output file. If I open the output file, it has all the lines back that we just read, right? So we just iterate through the array, and we just write the lines with the line break at the end. So this is your text file. Then the next part is the binary file. Binary file is a computer readable file which cannot be understood by humans, as it contains instructions. So for this we have the Python pickle library, and then we first of all have to know the syntax for that. In this, we just open the file, that is .dat file, the data file, and this is in WB format, which is write binary. And then in order to write any structure in binary, we have to use the pickle.dump function. This is built into Python. Here we give our data structure, and here we give the whatever the file handler was, and then we close the file. So if I run it, if I go and if I open the binary file.dat, it has something encrypted here or gibberish here. Okay, so once we try to read this, it would actually make sense then. So the pickle module is used for serializing and deserializing Python object structures, and it's a process of converting a Python object into a byte stream, and then we have to unpickle it to reverse it, and then you can store any Python objects or data like lists, dictionaries, or classes in it. Okay, now if I want to reverse it, I'll open the file in RB mode. This is read binary mode. Then I'll print out the contents by loading the file handler, the data in the file handler using the pickle.load function, and then I just print the value. So if I do it, okay, there is some error. I think the file was corrupted, so I just fixed the file. Okay, it's working now. So again, we run the code, it dumps the data into the file, into the binary file. We open the binary file, we use the pickle.load, and it works again. So similarly, if I have a class and if I want to create an array of class objects, and then I want to write them into the data file, so I'll just open the file in the WB mode, and then since I have an array of 11 indices, so I loop for 11, so for 100 times, and then I'm going to dump the values into my arrays into the file. So this is the car file, which is open in in the car file handler, car file.data file, and then this is the object that we are dumping every time from the array of car record into the car. And then if I run it, so it should go into the file, and that is the car file.dat. So if I open it, again it looks gibberish, but the data has been serialized. And then if we want to load the contents back up again, we need to open the file in read binary mode. We'll start with an empty array. We use the try except block and we check if there is an object here. So I'm going to try to load that object and I will end up appending it into my list, which is the car list. Otherwise, if there is an end of file error, then I'll break. Break simply means that we stop executing the loop, right? And if we try to print the value of car, hopefully we'll have some values here. Okay, yes, we have all the records here, so we can print these individual values one by one. Then random access using hashing. So again, we have to use the pickle library here. So for this case, we will use RB plus, which opens it in binary read and write. And then we have to use a hash function. This is Python built-in function, which will convert it into some fixed number string. And then we print the address. And then seek. Seek is a function that again will take the file pointer to a certain address. This is the address that we got, which should be some value, and then we take our pointer there and we are then going to dump the data at this pointer, and then we close the file. So that's what we're doing. So we generated a hash, we went to that address, and then we dumped that data into our file, and then we close the file. Now if we want to get the data back, so we'll open the file in read binary mode. Then we again hash a certain part of the data. So let's say this is registration number, which is the variable, which is a feature of this car. Then we again seek to that address. Then we are going to load the car file using the pickle.load to get the record from the file, and then we close the file, and then we can print the values and we'll get the values back. 0 car 2025. Right, so if I open it here, this was car file.dat. So again, this is all gibberish data, but we have successfully gotten the data back. That's the whole idea.